Alright, so let's have a look this time at finding zeros of parabolas with the quadratic formula. And we'll also just find the vertex to put together the whole picture today. So, let's see. We're going to go x equals, can you guys help me out? How's the formula go again? So negative b is going to be 5 this time, plus or minus negative 5 squared is 25, minus 4 times 3 times negative 4 over 2 times 3 is 6. Okay, so that's about what I'd expect you to do. Obviously, you're working with this. 5 plus and minus, and you go simplify inside. 2 negatives is positive, so we're going to have 25 plus something. 12 times 4 is 48. Yep. So we're going to have 5 plus or minus square root of 60 plus 13. 73, 6. 73 reduce, does 4 go in? No. Does 25 go in? No. 16? No. 9? Close, that'd be 63, right? 36? No, I think this is irreducible. So at this point, we just stick this guy in our calculator. Can you guys tell me what are the 2 decimals for this? Because you'd want to write it like that and then give me the decimals. If it's irreducible, what is it?
2.257.
Okay, I need confirmation. So let's see, 2.257. And then
0.591.
Confirm that Mary's correct. I'm going to do that on my calculator actually, just as we have it. If I do that on mine, let's see, if I go like this, right? 5 plus the square root of 73 divided by 6. Well, I got a different answer than Mary. Ashlyn? Doesn't it need to be all over 6? What did I tell my calculator to do here? I said go 5, just 5. 5. Plus the square root of 73 and take that thing only and divide it by 6. It's supposed to be everything divided by 6. Everybody makes this mistake though, but none of you guys are, right? So my everybody's a misnomer. I really should have gone like this, right? If I wanted to enter it at one time. So yes, looks good. So then you could go second entry minus, and there you go. Thank you, Mary. Okay. That's the zeros. What about the vertex? It's not in transformation form. I can complete the square to find the vertex, but we could also use that thing that says negative b over 2a, right? So we could go x equals negative b over 2a. That's the x-coordinate of the vertex. So if I want to graph this guy without my calculator, then I go, well, 1 zero's like here, 2, 3, the other zero's like here, the vertex is at like, what's 5/6 as a decimal? 0.8 something? I think it's 0.8 something, so that's going to be like here-ish, which makes sense because it's right in the middle, right? To find the y-coordinate, I'd have to plug 5/6 in. Is it going to be up or down though? Up, so if I plug that 5/6 in, I'm going to get clearly a negative number somewhere down here. The y-intercept is -4, so I didn't go down far enough. So if that's the y-intercept, then the vertex must be right here. You guys see how I'm really just problem solving that? That's what you should be able to do too at the conclusion of this chapter. Okay, so there's that one. Let's look at this guy. Quadratic formula time, one more time. So let's say x equals, help me out. Right? So we should have that. 1 minus is minus. 8 times 5 is 40. So this is going to be -6 plus or minus the square root of -4, which is -6 plus or minus, what's the square root of -4? 2i. So this is -6/4 plus or minus 2i over 4, which is -3/2 plus or minus 1/2 I. That's how you'd write that. It's facing up, right? So that says it has no real zeros. That says it's facing up. It's going to be a parabola above the axis. We could still find its vertex the same old way. Go -b over 2a. So 1, 2, its vertex is somewhere floating up here. How do I find this y coordinate again? I take that number. How do you find any y coordinate? And plug it into thing. I'm going to do that with my calculator, so a little calculator work. Let's see. I'm going to go 2 times -1.5 squared plus 6 times -1.5 plus 5. I got, let's see. Oh, I made a mistake. Got the wind again, it looks like. There we go. I got 0.5, so that's what I got. If this is 1 and that's 0.5 and this is -2, there's the parabola. Y-intercept should be, where should this actually cross? What? Where should this cross? Where's the y-intercept? 5, yes. 0, 0. So we're bringing this stuff all together. Right. So let's look at one last thing today and we'll call it quits and derive the quadratic formula tomorrow. I think we've seen enough problems with it now to where you guys should have a little bit of insight into what makes you have a real zero just once, what makes you have it twice, or what makes you have no real zeros at all, like that last problem. It's really just the inside part. Quadratic formula looks like this, right? Bless you. The part that tells you how many zeros you're going to have is just this part, because you either get plus or minus. If this part is 0, you get plus or minus nothing. And plus or minus nothing is one thing or two things. One thing. If it's plus or minus something, then it's how many things? 2. Those things could either be real things or imaginary things. So this guy inside, I'm just going to erase the surrounding part. This guy inside is called the discriminant. And it's what tells you how many zeros you're going to have. That's a nice shortcut to have access to. It's also useful in higher level math for a few things. So the discriminant tells you how many zeros you're going to have, so remember that. So let's look at a couple different cases of what it could look like. If the discriminant is positive, what's it look like? If the discriminant is negative, what's it look like? And if the discriminant is 0, like I was just talking about, what's it look like? If the discriminant's 0, then you have plus or minus nothing, but you've still got that part out in front. You've still got -b over 2a, so that's one real thing. What's it look like if you have one real 0 on a parabola? That's when the parabola does something like that and has one real 0. That happens when the discriminant is nothing. It could also, of course, be a downward facing parabola and look something like this. That would also have one real 0. If the discriminant's negative, then you've got plus or minus like -97. What's that? I. No zeros. So what's that look like? What's the parabola got to look like if that happens? Yeah. It could be like up here going this way. It could be like down here doing this kind of thing. That'd be the way it would look in that case. If it's positive, then you've got plus or minus like the square root of 100. So what's going to happen then? Yeah, that's going to be the majority of cases, kind of, where you have two real zeros something like that, or like this, with 2 real zeros, you know, something like that. So if the discriminant is positive, you get 2 real zeros. Oh, should have taken more time. If the discriminant's negative, you get no real zeros. And here you get 1 real zero. Let's look at a couple examples of like a parabola that's really close to one another but has different cases like this. We'll be done. So here's a few parabolas. Let's not actually find the zeros this time. Let's just say what kinds they are. So I'm not interested in doing the full quadratic formula. I'm just interested in finding what kinds of zeros there are. So what do you guys think I need to do with these parabolas first? Set them to 0 so I can actually like see what A, B, and C are, right? Not because I need to use the zero product property, but because I don't want to mix up which letter is which coefficient is which. So that one we're going to have the discriminant being, what's B squared?
144.
144 minus 4. A is 1. C is 36. Those are some big numbers, so I might need to go to my calculator. What's 4 times 36?
144.
Is it 144? Yeah, so from the calculator, that's 144. This time the discriminant ended up being 0. So not knowing anything else about this parabola, I know the most important part of it now. I know this parabola does what? It just touches the axis. I not only know that it touches the axis, I know its 0 is the same thing as its vertex. I don't even know what that vertex of 0 is, but I know exactly everything this parabola does. I know that it looks something like this, if its 0's over there. Maybe it's over here, but you guys get the idea, yeah. Okay, so let's do the same thing on this one. So we're going to go x squared minus 12x plus 40. This time the discriminant, that's not a 0. Let me make that clear. That's a D for discriminant. Write it out if you want to. It's going to be 144 again, right? Minus 4 times 1 times 40. So this time it's minus 160. That's negative 16. So the discriminant is negative. So what's this parabola look like? It has no zeros, and we also know, of course, that it's facing up. So this guy would look like some floating parabola like that. We don't know exactly where, but we know it looks like that, which is the main point. Same thing on this guy. So let's see. These are all really similar ones, just to show you what can happen. So that's one where it's going to cross twice. Okay, so it looks something like this. With our 2 zeros. Okay, guys? I thought we'd look at one more example using the quadratic formula before we go ahead and derive where it came from, one possible way to do that. So let's apply the quadratic formula to this function and find its zeros. So we've got it already nice and lined up, the coefficients A, B, and C, all quite clear. So negative B, going to be negative 8, oops, plus or minus the square root of negative 8 squared minus 4 times A times C, all over 2A. I think that's just going to be negative 8. All right, so now we've got 8 plus or minus that's 64 in there, positive 64. 3 negatives makes a negative. Always careful on that one. Now we've got 16 times 12. You can whip out your calculator and get that. I think that's 192. So then we're going to have, let's see, 8 plus or minus the square root. 64 minus 192. Might need to grab your calculator on that one. Is it negative? Well, I'm just going to do it. Let's see. 192. Negative 128. There we go. So then keep simplifying. So it's going to be 8 over negative 8 plus or minus this guy over negative 8. So that's clearly just negative 1. This guy breaks down. You want to think about what square numbers go into 128. I think 64 does. That's you should recognize from your power tables. Excuse me, that's how I recognized it. 128 is 2 to the 7th power, so divide that by 2 and you get 2 to the 6th power, which is 64, and that's also a square number. So those power tables sure are nice. So you got 64 times 2, and the square root of negative is, of course, I. Square root of 64 is 8, so we've really got 8 over negative 8, which is negative 1, and then we've got a square root of 2 and an I left over. So there's the zeros. They're clearly imaginary, so this guy's not going to cross the x-axis. It has no x-intercepts. Let's find its vertex in order to see, where exactly it is. So if we go negative b over 2a, Mr. Negative, that's going to be 8 over negative 8, which is negative 1. So this guy's going to look something like this. If that's the axis of symmetry at negative 1, we can also find the y-intercept by just plugging in 0, of course. That's going to be negative 12. So the y-intercept is here at negative 12. We know it has no zeros because they're imaginary. And if that's the way it looks, and it's also facing down, then it's going to be something like this.
Michael Harris, please come to student services. Michael Harris.
If you want the actual value of that vertex, you can of course take negative 1 and plug it in. But it's obviously got to be somewhere between 0 and negative 12, maybe like negative 6 or something like that. Okay, so there's one more example with the quadratic formula. Let's derive where it came from. So quadratic formula can be obtained a variety of ways. You can use geometry and look at actually squared stuff. It's usually a little bit more intricate. I'm going to do it with algebra. I'm going to use the technique we just learned, completing the square. So let's go back to the most basic parabola. ax squared plus bx plus c. That's what we want to be able to solve when we're using the quadratic formula. So let's set that to 0 and try to complete the square on it, and we'll just see what happens. So here we go. I'm going to set it to 0. So that's pretty much what we always do when we're trying to find x-intercepts or zeros. And now I'm going to complete the square. You have to be careful here because everything's symbolic. Other than that, it's just kind of a lengthy or trickier completing the square problem. So if we were to complete the square, we usually have to factor out this a, right? So what's left is x squared. And then this is tricky. Remember, when you say factor out, you really mean divide. So it's really going to be plus b divided by a x. The next thing I do when I complete the square is I add that magic stuff that turns it into a perfect trinomial. So how do you do that? On this it's symbolic, but you want to just go back and think about the idea of completing the square. Usually take this coefficient right here, cut it in half, and you square it. Let's do a little scratch work. So I'm going to take that coefficient, I'm going to cut it in half. That's the same thing as writing it like this. So if you write this as 2 over 1, you flip it, and the 2 goes on the bottom. There's b over 2a again. You should recognize that. This should be looking okay already because of the b over 2a. So that's it cut in half. You also need to square it. So that's going to be b squared over 4a squared. So that's the magic stuff we're going to add right here. And we're adding it, right? So make sure that's clear that that's a plus. You know what? I'm going to space this out a little bit. So I'm adding b squared over 4a squared. We've still got our c floating around. I'm going to erase my scratch work now. Okay, so I've made this trinomial complete by adding that magic term. We always have to compensate for that, though, if you remember. So what did we really add when we put this blue stuff here? Well, we really added this. We really added a times it. Since that's multiplication, the a's are going to cancel. One of them is anyway. So that's what's left. So I really need to subtract this guy out here. So now let's see what's left. Remember, when we complete the square, we're making the trinomial perfect so that it compacts down or factors down in that nice predictable way. So now I've got a times the quantity, what being squared. What squared gives you this perfect trinomial? See, here's really where the abstract notion of the algorithm becomes important, and where you can't just look at it and guess it. So remember, what we do is we always go x, we pull this sign down, and what goes here is half of that, which we had on the board. I guess I shouldn't have erased it.
Will you please come to the student services outside and Dennis?
So we shouldn't have erased it, I guess, from a second ago, but that's half of that middle term. And then we just got to look at what's left over here. So we've got minus b squared over 4a plus c. Okay, so we're trying to complete the square and solve for x, right? So we've got 0 over here. So I'm going to subtract this and add this. So I've got c plus, I should say, well, do it backwards. So I'm going to have b squared over 4a plus c equals a times this quantity. And we're just solving for x, remember. So the next step is to divide a on both sides. So I'm going to divide a everywhere. There's a divided everywhere. That gets rid of it. So now I'm going to come over here and I'm going to make this a common denominator. So this guy's got 4a squared on it. This guy, I want to have a common denominator, so I'm going to use a clever one. If I want a squared, I can multiply by another a. So now I'm going to have plus ca over 4a squared. I think I made a little mistake there, if you think about it. Those don't have quite a common denominator yet. They both have a squared, but this one's missing the 4. So let's also stick that in. So this should be 4ac, or 4ca, equals the quantity squared. The next step is to, remember, don't get lost. You're solving for x, so I'm going to square root both sides. When we square root an equation, we get plus or minus as a side effect. So now we've got x plus b over 2a is plus or minus this square root. And these have a common denominator now, so I'm going to write it as 1. You could have done that on the previous step, or right now. So I need to actually have a mistake here I just noticed. I should have subtracted c on both sides. So this should be minus. And so should this. And so should this. You can already see the quadratic formula developing at this point. We've got 4ac right there. So now let's think about one more thing we can do. We can now subtract this and we'll kind of have it ready to go. So negative b over 2a plus or minus this stuff. Have x. That should look like your quadratic formula. The only thing is, it's all over 2a in the quadratic formula, right? So the square root can't really go across the top because there's these two separate terms. But on the bottom, there's just one term. And the square root of 4 is 2. The square root of a squared cancels to a. So really, you can really just write that like this. So you can go, that's just the square root there. And this is all just 2a there. Those have a common denominator, which is the whole reason the quadratic formula is all over 2a. And there you have it. There's the quadratic formula, or where x equals those combinations of coefficients. Hope that was enlightening. I'll see you next time.